Welcome back everyone to the Hello World guys. This is another episode of the SFML Dodger game series, and in this video I have actually implemented a couple of things that we are going to have a look over and just kind of understand what I did. So let us start the game, and the first thing I did is that I randomized the enemy movement. Now enemies also move horizontally but only a little bit, and the player can no longer go out of the screen, and because currently the player could go out of the screen, now it cannot. And another thing that I've changed is that enemies have different vertical speeds, and yeah, that's basically what I have done already, and I'm going to give you an overview of the implementation so that you can try to implement it yourself. So first thing I've done is that I've created a new vector here called enemy speeds, which is of type vector2f, so that it can store the horizontal and vertical both axes of the enemy speed in a separate vector, because we don't have a class for the enemy, we just have rectangle shape, we did not have a variable for speed. So we are doing this now. Now that's pretty awesome, but we are after setting everything, and here after the pushing back enemies, we are getting another value here for push underscore back for the enemy speeds, and in here we put a vector2f. Now what that does that vector contain? Let's first look at the y-axis, and what this contains is that it essentially you can see that we have got we create a random number using our distribution that we have got, and then we use the modulus operator to do it by 11, which means that it will give us a number between 0 and 10, not 0 and 11, 0 and 10. And what we do is that with that number from 0 to 10, which is an integer and too large for our enemy speed, we divide it by 200, which makes it from if I'm not wrong, it makes it from 0.05. So 0 to 0.05, and our original enemy speed was 0.05. And then what we do after dividing it is that, by the way, you must add the decimal point here, or else it will take it an integer and the division will be 0 and nothing will work. And when we have got the 0 to 0.05 thing, then we add 0.025 to it, which makes it be a random value from 0.025 to 0.075, which is quite interesting. And in the x we do basically the same thing, but since we want very little movement for the x, we do just 2000 here instead of 200, which makes 0.005, not 0.05, 0.005 with okay, with the 2 of this. And then we go ahead and say I, and we multiply it by value of depending on the I. So if the we use the ternary operator here, and if the I is less than or equal to 1, then we put 1 here, else we multiply it by -1. What's the purpose? So for the first two, 1, which means 0 or 1, or you can actually say I is less than 2, which is basically the same thing, but it's a bit more understandable, I guess. So if for the first two of the enemies we want them to move positive direction, which means from left to right, but for the other two we want them to move in the opposite direction, so that none of them go out of the screen immediately. And we essentially do the same thing when we are doing here. We also set the enemy speeds I is equal to this, and when we are moving the enemy, we just take the enemy speeds I and do that, and we do it again here when the enemy's position goes out, so that we have got different speed whenever the enemy comes again. And that was for the randomization. And as far as the player position is done, we have got basically two more if statement here, which is that if the player position on the x is less than 0, then we set it to, on the y it remains original obviously, but on the x we set it to 0 again, which prevents it from going below 0. And if it's greater than 800, -60, because we don't want the player to like go out of the screen at all, but we want it to be blocked here. So our screen is 800 and we -60, which means that the player will be blocked here, since the origin is at the top left corner, so we need to subtract 60, which is the size of the player. And if that is the case, then we set it to that value, 800 -60, and the y remains the same. So this was pretty much the overview of today's video, and let's start and see whether our stuff is working. And you can obviously tweak those values according to your liking to make them kind of like whatever you want. And you can see we have got a pretty nice game going, but there are a couple of things that we have not yet implemented, and I want to implement those. The most important is that currently we have got no game over screen or anything, which makes the game kind of boring, and we have got no proper update function, which means that our game is running at wrong frame rates. We don't have any frame rate controlling system, no proper loop system, which is resulting in a couple of problems, which we will discuss in the future videos. So yes, stay tuned for that. I will see you in the next video. Make sure to like and subscribe as well, and bye.